The recording has started. I am going to share my screen with you. Did I do it right? Oh, boy, if you don't get out my face, you know I handles mine. Go, I can't be saying, on the camera. You get me in trouble.
You know me to normal.
Yeah, but no. But you listen, I take roll because we are held accountable for that. What? They don't be playing. This virtual environment is a little heavy. You know what I mean? Because we are clearly held accountable all across the board. You see, I record the class every day. All right, so here's where we start, ladies and gentlemen. For those of you who have been in class on a regular, you have probably seen this a time or two. For those who are just returning, these are the three distributions, or these are the three shapes of distributions that we have been discussing. So if it's left skewed, remember the tail of the data is on the left side of the graph and the data has been pushed to the right. And in that situation, you see the median falls here. The median of the upper portion of the data is greater than the median. The median of half of the data falls here. The median of the lower half falls here. So you see the median, the median does not necessarily, if it is skewed, the median does not necessarily split it in half as we are used to seeing, but it means that 50% of the data falls to the left and 50% of the data falls to the right. So when we look at the same configuration, a skewed left box plot, remember that the tail on the left, or the whisker, on the left is longer than the whisker on the right. And the median of the data set is closer to the median of the upper end of your data. Now, depending on whose configuration you see of a box plot, it may not be horizontal like these. We are used to so far seeing them horizontal, but sometimes you will see them vertical. So the right whisker and the lower whisker, the right whisker and the lower whisker are synonymous. They are the same. And the upper whisker or the right whisker are the same. Excuse me. Sorry about that. Okay, so those of you who are taking notes, what you need to write is, for a box plot, left skewed, and remember a skew is just a push or a slant. Left, and in parentheses, put the word lower. Whisker is longer than the right. In parentheses, put upper whisker. And next, you are going to put Q2 is closer to Q3. And that just means that the median of the data set is closer to the median of the upper portion of the data. Because we, again, know that the median split the data 50-50. Second, if the distribution is symmetric, that means left side looks like right side. The same configuration that you will find in a histogram, you will find in a box plot. So if the distribution is symmetric, the median falls directly in the middle. In this instance only does left side look exactly like right side. Same configuration in the box plot. The whiskers are the same length, and the box itself is split into 2 equal parts, again, by the median of the data set. So it is equidistant from the median of the lower portion of the data and the median of the upper portion of the data. And lastly, if it is right skewed, that means the tail of the data is on the right side and the data has been pushed left. So in that instance, again, if it is a histogram, again, the median of the data set is closer to the median of the lower end of the data. And the right whisker, or right or lower whisker, is longer than the left, and in parentheses, lower whisker. Okay? So those are the characteristics that you will look for when you determine left skewed, right skewed, or symmetric. So your assignment for that second checkpoint was to critically analyze what you saw and match the two, a histogram to the box plot that is graphing the same data. So you're going to look for these things over here. You're going to check the shape. You're going to look for the max and the minimum terms. You're going to estimate the median, and then look for outliers, because there are things, or there are signs in the box plot that will help you match it to the histogram. So when we look at the shape of the histogram, and remember, you see there are no spaces. When you look at the shape, you see that the majority of the data is on the left side. So that means tail would have been on the right side, majority of the data on the left. Because this number, because this is sitting out here, it is an outlier. And you look for, in the notation of the box plot, you look for an outlier. An outlier is noted by either a circle, as it is here, or an X, depending on the author of what you're looking at. And we see this box plot is vertical, it's not horizontal. So that's why I said upper and lower when I was talking about the whiskers. Okay, so max and min. They used a 5, good morning. They used multiples of 5 to denote the years. However, that is not the same scale that the graph used. So you had to figure out that they were, first of all, counting by 2s. Oh, sorry. They were counting by 2s. So 2, 4, 2, 0, excuse me. 2, 4, 6. 5 does fall midway between 4 and 6. 8, 10, 12. So therefore, the maximum value is 12. It is not 15. Okay, so minimum 0, maximum is 12, because they are talking about the main body of the data. Okay, to estimate the median. Now, in looking at a histogram, you must remember that the median just means half. Okay, and when we divide something in half, what is the percentage that we are looking for? What happened? What are the percentages on either side? When you split something in half, on the left side is what percent, and on the right side is what percent? if I say give me half, what percentage are you giving me of what you have?
50%.
Thank you. So we are going to remember that the median just means 50%. Okay? So when we look at the histogram, if we want to speak about the median, and for those of you who did the first checkpoint, this should come back to mind for you. Here, if we want to look at the histogram and determine the range that the median falls in, how would we do it? Does anybody remember? What did you do in that checkpoint 1? Because the last claim on checkpoint 1 said the median falls between $250 and $500. That was the question from checkpoint 1. Use that same train of thought because you had a histogram. Where would the median fall if we were looking at this histogram only? Remember, the median is 50%. What would you do?
That's required. Never mind.
Come on. What would you do? What are we trying to get to? How much percent? Because we want the median. So we trying to get where? To what percent?
50, right?
50. All right. So now, train of thought. We trying to get to 50. We start at 0. Where will we get, when we hit 50, where will we be on this graph? Between what and what? Some of y'all did that checkpoint and answered that question about the median.
Say that again, Miss X. Say that again.
Okay. So my question is, if we trying to get to the median and we understand that the median is 50%, I asked, where will the median, if we just looking at the histogram, where will the median fall? It'll be between what and what? And I said, use the same train of thought that you had to use on the first check or the first cool down when it asked you that question about does the median fall between $250 and $500? Oh, so ladies and gents, I'm going to tell you, you are trying to get to 50. We are starting at 0, right? So between 0 and 2, how many do we already have? Look at the top of the bar. How many does that first bar? Yes. So that first bar accounts for 40. We trying to get to 50. So where does that take us? We are in the first bar. We only got 40. We trying to get to 50. So now where do we go?
The second bar?
Exactly. And how much do we need of the second bar to get us to 50?
Just 10.
Exactly. So, ladies and gentlemen, that means that the median has to fall between 2 and 4 because we need everything from 0 to 2. But we just got to dip in here a little bit and get 10. So that means even though we don't know exactly what number it is, we know it's going to fall between 2 and 4. Make sense?
Remember,
anytime you talking about the median, you are looking for 50. You're looking for 50%. If they say find the median, and if the first bar only has 10, keep moving because you're trying to get to 50. If the second bar got 20 more, now you got 30, but keep moving because you still need to get to 50. But for us in this particular histogram, we had 40 when we got to 2. So that means when we get to 50, we're going to be somewhere in here because we're going to take 10 of these to help us get to the median. Make sense?
Yeah.
Okay. So median match up. We know it's somewhere between 2 and 4. Look at the box plot. Somewhere between 2 and 4. Then we look for outliers. Anything that is not connected to the main body of the graph. So this is the main body of the graph. So this main body of the graph is what is being displayed here in the box plot. The thing that sits outside. It is an outlier. It lies outside of the majority of the data. Okay, so that's something else. If you ever have a graph and you're doing this matching, look for the outliers first because they stand out. Okay, so we see here that we had the median, we got the max, the min, and the outlier, and that was enough data to know that these two match. Okay, and this will be skewed right. And from our definition, if the box plot is skewed right, the upper or right whisker is longer than the left or lower whisker, and the median, our Q2 value, is closer to the median of the lower end of the data, our Q1. Okay? Critically analyze what you see. I don't know what you all will do with your adult lives, but you may come across some graphs and you need to be able to read them. Okay? So, what I just wanted to point out in this one is the outliers for the box plot, they are clearly marked. Okay? So, if these were the two that you needed to match, look for the outliers first, because that is the thing. They lie outside. They stand out. So look for them first, and then go back and critically analyze your data. Okay? So let's do this quick little practice. So now, look at this. We have 4 situations here. We have 4 histograms up top, 4 box plots. We are going to match them. Again, this was what Cool Down 2 was emphasizing. So now, when we look at histogram A, would you describe it as skewed left, skewed right, or symmetric? Again, skewed left means the tail of the data is on the left side, and as the data moves right, it grows, so it skewed, pushed it. Symmetric, the left side looks like the right side. If we were to split it in half, we could lay it over on top of each other. Or is it skewed right? The tail of the data is on the right side, and the most of the data has been pushed left.
Is it skewed right?
All right, so it is skewed right. So if it is skewed right, think about the characteristics of the box plot. The right or upper whisker is longer than the left or lower whisker, and the median is closer to Q1. The median of the data set, Q2, is closer to the median of the lower end of the data, Q1. What's the mate? A matches with which number?
Wait, 4, right?
Yep, bam. A matches 4. So again, we see here, this again, they have turned the box plots from horizontal, like we're used to seeing it, to vertical. So if we were to turn this vertical, we would turn clockwise. So the right whisker is longer than the left whisker. So that means the upper whisker is longer than the lower whisker. And our Q2 value, the median of the data set, is closer to Q1, the median of the lower end of the data. So yep, that is 4. So now let's look at B. And again, we are critically analyzing. So what does B have that A, C, or D does not?
It's big.
It's B.
It got outliners, right?
It has, yes, it has outliers. So that's what you look for. The outlier is sitting out there all by itself. So yes, in your box plot, look for the outlier. Absolutely. All right, let's talk about C. C, left skew, right skew, symmetric. What you thinking?
Right.
Okay.
Left skew, right?
Left skew. So C is left skew. So we either have 1 or 3. What's the mate?
Is it 1?
Absolutely. So if it is left skewed, remember that the left or lower whisker is longer than the right or upper whisker. And the Q2 value, the median of the entire data set, is closer to our Q3 value, which is the median of the upper portion of our data set. Yep, good money. So that leaves D. D, left skew, right skew, symmetric.
Symmetric.
Symmetric, absolutely. So if we split this straight down the middle, left side looks just like right side. So in our box plot, top should look like bottom. So we see the whiskers are the same length, and the median clearly split the box in half. So the distance between Q2 and Q1 is the same as the distance between Q2 and Q3. Yep. So that was your task, ladies and gentlemen, in the second cool down. To critically analyze, critically look at what the histogram is telling you and match it to a box plot that is telling you the same thing. Okay? So, for those of you who are on cool down 3, I am going to mention it here, and then people who are still on cool down 2, we will talk about that a little more in detail because we got about 5, I could push it to 10 minutes. So, for those of you who are on cool down 3, the question is, which measure of center should you use? They give you the 3 distributions. They give you the 3 shapes. They give you a symmetric distribution, a left skewed, and a right skewed. And they are merely posing the question, what's the best measure of center? So, should it be the mode? Will it be the term or item that appears most often? Will it be the median? Will it be that measure that splits the data 50-50? Okay, again, The pieces may not necessarily look alike, but as we just talked about in that histogram, where do we get to the point where that is 50% of the data on one side and 50% on the other? Or do we use the mean? And the mean is the arithmetic average. You added them all up and you divide it by the number of terms. So 3 is asking you, which one of those should you use given each of the 3 distributions? And again, for those of you who have been here, if you've been taking notes, remember, these are things that we discussed in the beginning. So look at your notes from the first week or go back to the videos of those first couple of days. And that is where we discuss this. Okay. The videos are posted. And I do still owe the videos from this week, but all of the videos prior to this week have been posted. Okay. So with that said, my darlings, let us look at checkpoint 2. So what I want you to do is open another tab, and I want you to get onto checkpoint 2. And let me make sure I'm not in anybody's account. So, okay, yes. So those of you who are on checkpoint 3, work on it. Okay. But I'm going to discuss checkpoint 2. Are we ready? People who need checkpoint 2? All right, let's talk about it. I see graph E first, so that's where I'm going to start. So first, look at the scale down the bottom. We see that the graph itself goes from 52 to 88. Okay? Critically analyze what you see. He's silly. Okay, so you see that the graph goes from, like I said, 52 to 88. And then you see there is some data, 3 pieces that fall in the 50s. You see the bulk of the data falls between, let's say, 65 and 73, let's say. And then you have some more data out here in the 80s. Well, you know that because the bulk of the data is being graphed between 64 and 73, what is happening in the 50s and what is happening in the 80s are the outliers. Look for the outliers. So now scroll down to the bottom of your page. Look for the box plot that has 3 outliers in the 50s, 3 outliers in the 80s, and then has the box plot, the bulk of the data, graphed between the 60s and the 70s. Remember, the box plots are numbered with Roman numerals. So those are I's and V's. They are not L's. Now you can type onto this document. You can click under the graphs themselves and you should be able to get a cursor to allow you to type. Okay? Now, you should have gotten number 4, IV. You should have gotten number 4. So if you look at the graph, you will see there are 3 circles, round 53, 56, 57. Then you see the bulk of the data, which is the box plot. You see that in the 60s and the 70s. And then you see to the right of the graph, you see those outliers in the 80s. So you see one at 80, one at 84, and maybe one at 85, or maybe 83 and 84. But the point is, you see the correlation. 3 outliers in the 50, bulk of the data. No, you got to do it at the bottom. At the bottom. All the way at the bottom.
All right.
Yeah, for people doing checkpoint 3, thank you for pointing that out. For people who are doing checkpoint 3, it will not allow you to write in the boxes next to the diagrams. You got to go all the way down the bottom. Okay? All right, so back to this, because we got about 4 minutes before we need to break and go to the all school assembly, and you all should have the invitations in your emails. So now, let's look at what I see. My next graph is the letter C. So I want you all to look at C. So in C, we see we have the bulk of the data. We got the body of the data. First of all, back up. Let's look at the grid. We see that the grid goes from like 46 to about 80. Okay, so off the bat, that bottom axis, 46 to about 80. We see the body of the data is happening between the 40s up into the 60s. And then again, we have these outliers. We have 2 of them, and they are both happening in the 70s. One is happening somewhere between about 72, and the other one is happening around 78. Scroll down to the bottom. Look at your box plots. You are looking for, because they are easiest, because they stand out, because they are outliers, you are looking for a box plot that has outliers, 2 outliers to the right of the box plot in the 70s. So again, remember they are Roman numerals, V's and I's. Match them up. Let's talk about what I see next is B as in boy. Again, looking at the graph, let's look at that bottom axis, that grid across the bottom. You see it's starting a little before, well, let's say it goes from like 40 to about 75. Okay? Then again, let's talk about what we see. We see that there are 3 bits of data happening in between 40 and 45. We see some action happening or some data happening between 50 and 55. We see something else happening between 55 and 60. And then we see the bulk of the data happening between 65 and 75. Yes. Okay, thank you. Okay, so again, I'm looking at graph B as in boy. We have some data, 45, between 39, 40, and 45. We have some data, 50 to 55. We have some data, 55 to 60. And then we have the bulk of the data happening 65 to 75. Scroll down to the box plots. Which box plot has those same characteristics? Okay? And that is what is expected of you in this. This is to get you to think critically, pay attention, analyze what you see. Okay? And then look at the box plot that is graphing that same information.
Hey, Lisa.
Yes.
I gotta leave for work.
Okay. All right. So that means you're not coming to community meeting.